Every Android application you have ever built has logging issues, you just don't know it. Think about it. Right now, somewhere in your codebase, there is a Log.d call that prints authentication token directly in your Logcat. There is a view model logging raw API responses that contains phone numbers, email addresses in them. And all of this thing is happening because your Log.d does not care in which environment you are in, whether you are in the debug environment or in the production environment. And this is only the security side. What about when a crash happens? Your crash reporter might give you the state trace report. Great. However, what was the user doing 30 seconds before the crash? Which screen they were on, which API call failed? You have literally no idea because your logging has no memory, no pipeline, and literally no structure. Most developers solve this issue by adding Timber. Timber is very great tool. I have used it for years. But Timber is a global singleton with no dependency injection, no interception pipeline, no sanitization layer. You cannot give different module different logging behavior. So I sat down and built a complete core logging module. I have used here solid principle. I have used here logger interface. You have the filtration layer. You have the interception layer. And apart from this, you have a formatter layer. Like if you want to deliver any crash report to your quality assurance team, things are different there. And if you wanna deliver this same report to any normal user, things are different over there. So you should have a formatter that do the formatting for you so that you can convert the crash report into human readable format. We have a layer for this too. I will give you an option. If you want to inject your logger with Hilt, you can do it very easily. Or if you want to create your logger manually for different module, you have the power to do that. Enough talking, let's get started with the coding part. Literally, you're gonna enjoy this coding because we will learn a lot of things, and also we're gonna see how a very simple looking thing become very complex when you use solid over there. So let's get started with our video, and do not afraid, solid doesn't mean it's very complex. Sometimes for the some people who just started with the solid might think that this coding is very complex, but it is not. When you are working in big project, big MNC project, you should use the same patterns, the same exact pattern that I am going to show in my code logging module. So let's get started with our video and let's deep dive in it. Before start writing any piece of code, we shall try to understand what's the problem and how we gonna solve that problem. So what's actually wrong with how we log? 4 things. First, it leaks in the production. Log.d does not care about your build type unless you wrap every single log call in if build config.debug. Your debug logs ship to the users. I have personally seen authentication tokens appear in Logcat on a production device during a client demo. That's not a theoretical risk. That's a carrier moment. Second, there is no interception point. You cannot sanitize the information. You cannot attach metadata like user ID or screen name. You cannot route certain logs to your crash reporter. Every log call is fire and forgot. Once it executes, you have zero control over what happens to that data. Third, it is untestable. Log.d is a static call into the Android framework. You literally cannot verify that a class logged the right message at the right level without bringing in Robo Electric or Power Mojito. So either you don't test logging or you add heavyweight dependency just to check a string. Fourth, it violates every solid principle. Your view model is deciding the log level, the tag, the format, and implicitly whether to log at all. That's 4 responsibility tangled into one line of code. Let me show you code I have seen and written in production. Look at this. 3 log.d calls in a view model. The first one logs user data. Fine, maybe. The second one logs an authentication token. The third one logs a credit card reference, both highlighted in red because both are a compliance nightmare. And here's the thing, there is no build type check. This runs in debug and release. There is no sanitization layer between your code and Logcat. If someone connects a device and run ADB Logcat, they see everything. Now, most developers solve this by creating a log utils file with 20 static functions. One for debug, one for release, one with tag, one without. And 6 months later, that file has 40 different functions and nobody remembers which one to call. That's not the answer. The answer is proper module with a pipeline. Let me show you what that looks like. Here is the core idea. Every log statement flows through a structured pipeline before it reaches to any output. Step 1. You call logger.e or logger.d, whatever label you need. That creates a log entry, an immutable data class with label, tag, message, throwable, timestamp, thread name, and metadata map. Step 2. Sanitization. Before anything else happens, the sanitizing filter scans the message for passwords, tokens, credit card numbers, and redact them. This runs first so that no downstream component ever see the raw information. Step 3. Filtering. Should this entry be logged at all? The label filter checks minimum label. The tag filter checks allow list and block list. The rate limiter filter prevents flooding. If a tag logs more than 10 times in a minute, the rest get dropped. Step 4. Interception. Interceptors transform the entry. Tag prefix interceptor adds your application name. Metadata interceptor attach user ID, screen name, session ID. Crash breadcrumbs interceptor save it to a rolling buffer for crash report. Step 5. Dispatch. The entry goes to every registered logger, Logcat, file, crash reporter all at once. The call site does not know or care how many destinations there are. Below that you can see the module structure. 8 packages, each with one job. Model, configuration, formatter, filter, interceptor, logger, extension, and dependency injection. We'll build every single one. Let me break down exactly what we are building. 6 features, 6 layers. First, the logger interface. Clean method overloads W, E, and WTF. Each have 2 variants. One with a throwable, one without. No nullable confusion, no default parameter that compile but crash at runtime. Second, P2 sanitization. A sanitizing filter that automatically redacts passwords, tokens, credit card numbers, and emails using regular expression patterns. It runs before any other processing, so no downstream component, not Logcat, not your crash reporter, not your file logger ever sees a raw sensitive information. Third, crash breadcrumbs. A crash breadcrumb interceptor that keeps a rolling buffer of the last 50 log entries. When a crash happens, you call get breadcrumbs and attach them to a crash report. Instead of bare stack trace, you will get 50 entries of context showing exactly what happened before the crash. Fourth, smart filtering. Level gates, tag allow list and block list, and per tag limiting. Rate limiting is the one that saves you when a WebSocket reconnection loop fire log it on 200 times per second. Fifth, the interceptor chain. Tag prefixes so you know which module a log came from. Dynamic metadata like user data, screen name, session ID evaluated at log time, not constructor time. Sixth, Hilt integration. To Dagger modules, inject logger everywhere. 0 setup code in your application.onCreate. 28 source file. 11 test files. 1100 line of kotlin. 0 third-party logging dependency. Now I know what you are thinking. Why not just use Timber? And look, Timber is cool. I have used it for years, but let me walk you through this comparison. Dependency injection. You call timber.d and hope the right trees are planted. Core logging uses constructor injection. You inject logger into any class via Hilt. P2 sanitization. Timber does not have it. You'd have to build it by yourself. Core logging has an automatic sanitization pipeline built in. Per module loggers. In Timber, every module logs through the same global tree. In core logging, you can scope loggers via Hilt. Your network module can have different filtering than your UI module. Interceptor chain. Timber give you tree.log and that's it. Core logging lets you chain and interceptors in order. Prefix, metadata, breadcrumbs, whatever you need. Rate limiting, not in Timber. built into core logging with a per tag sliding window. Crash breadcrumbs, manual step timber, built in interceptor in core logging. Testability, timber needs timber.plant in your test setup. Core logging, inject no op logger, and we are done. This isn't about bashing timber. Timber is a great library for simple projects. Core logging is what you build when you have outgrown it. Before we jump into the code, I want to show you how solid principle map to actual decision in this module, not theory, practice. Single responsibility. Each package has one sentence of purpose. Filter decide whether to log. Formatter decide how to render. Interceptor transform entries in flight. Logger dispatch two outputs. If you cannot describe what a package does in one sentence, it's doing too much. Open closed. I did not plan for JSON log formatter from day one, but because log formatter was an interface from the start, adding JSON output was a 20-line class that touched nothing else. Same with the rate limit filter. Added it without modifying label filter or tag filter. You extend by adding, not by changing. List cost substitution. No op logger is fully substitutable for Logcat logger. Both honor the same contract except a log entry. The caller doesn't know or care which one it has. In tests, you inject no op logger. In production, you inject Logcat logger. The code that uses them is identical. Interface segregation. Logger has one method to implement, log. If I put config, filtering and formatting on the same interface because they are logging related, every new feature would ripple through every implementation. Dependency inversion. Every constructor takes interfaces. Every test provide test-friendly implementations. No mocking frameworks needed. No Power Mockito, no RoboElectric. Just a clean interface and a recording logger that capture what was logged. This is what solid looks like when you actually apply it. Alright, that's the why, that's the what. Now let's build it. We're going to start with the model layer. Log level, log entry, log destinations. The foundation that everything else depends on. Then we build up layer by layer config, formatters, filters, interceptors, the core logger interface and composite logger extension function, and finally the Hilt dependency injection wiring that ties it all together. By the end, you will have production ready logging module. Every class tested, every line of P2 read at, every crash report loaded with context. Let's get into the code. So let's start the coding part. So first thing first, you need a project. I have already created a brand new project and right now I'm in the project. You can see over my computer screen, and in this project I'm gonna create here a new module which is core logging module. So in order to create module, and to be more specific, this is not Kotlin or Java library, it's an Android library because logging logcats that we have in our Android is a part of our Android framework. So we cannot create a Kotlin or Java library. So we should need here a proper Android library. So to create a new module which is an Android library, what you should do, go to your file, new, and here you can see we have new module. Click on it. It provides you a bunch of options and we are interested in Android library. Name is core dash logging. For the package name, I'm using here capital L, core logging, and rest of the things just leave it. Click here, finish. It will take few moments to create your new module, and once it's done, we will begin our journey for logging module. Okay, so here it is. We have our core logging module. Open the manifest. So we have nothing. Open the Kotlin plus Java first developer Himanshu core logging, and we are not getting anything by default. So it's time to create it. So first thing first, what we shall begin with? We shall begin with the immutable data class that holds the complete information about our logger, and this is the only single data class or model class contains the information about our logging. So for that, first I'm gonna create here a package, and the package name is model, and in this first we will create our log labels. As you already know, Android system provide us a lot of various kind of loggers like verbose, debug, then we have error, assert. Like this we have various kind of loggers. So first thing first, we got to create a log level class, enum class, that has all of this information in it. So for that, create here a class, and the class name is log level. So it basically tells us the level of our log. It's an enum class, and in this enum class, make sure to pass priority, and I'm going to use the same priority which is used by our Android framework. So priority type is integer, and in this we will create our log level. So first thing first, we have in it verbose, and its priority is 2. I'm using the same exact sequence what Android system uses under the hood. So first it uses verbose, then it uses debug, priority is 3, then it has information, priority is 4, then it has warning, priority is 5, it has error. So this error usually we'll use in production application, because we want to track what's going on. If anything goes wrong in our production application, this is the error log level that we should use to get the complete information what's going wrong over there. Now for the error, I'm using here 6. Next we have assert, priority is 7, and lastly we have none, and for none I'm using here integer maximum value. So now we have the log level, and each log level has its priority, and I'm using the same priority which is used by Android framework under the hood. This also contains a function is at least. This function is very easy. It simply help us to check current log level priority with the past, which is other log level priority. So we simply check priority is greater than or equal to other priority. So this is what we have in our log levels. We have various kind of log level like the verbose, debug, information, warning, error, assert. None is eventually added by me. So these are the log levels we have for our core logging module. And now it's time to create the only data class that holds the immutable information about our logging.